Hello everyone and welcome to my Java programming tutorial. So this video is part 2 of linked list. So before watching this video, make sure that you have watched part 1, which is linked list introduction in PowerPoint slides. Okay, so I will be doing the same coding. We will be recreating the LinkedIn class like in Java, which Java has already created. So we are recreating that class, and this class will only work for integers. You can create for doubles, strings and character just in the same way. Okay, so let's create our first class, that is our list node class, because linked list consists of list node and each list node will have, so let me see, so this is your programmer's class. Like, this is kind of a back-end coding which client won't see. So in your list node, as you remember or recall from our previous video, list node is a box having int data, and we have an address to what? To the next list node. So the data type for the next list node will be is the same because it's holding another list node. You can name it anything. As from the programmer's point of view, we usually name it as next, which represent that this is the next list node, like that whole box again. If there are no other list node, this next will be null. And just like from our very first week, from the very first day we studied like classes and objects, there we learned like how we have to create these programmer classes where you have to identify the fields, which are these two things, and the next part is identify the constructors. Constructors are always public. They don't have any return type. They have the same class name. And what we are asking from constructor is depending on your fields. So maybe your user is only passing you the data value and is not returning you the address, for just like this one, the next. So what we will do is this dot data will be equals to data, and we will say this dot next will be equals to null, because maybe this is the value where user will only give you, hey, this is the data value, and you will add that value at the end. And when you are adding the data at the end, so it means this will be null. The address of the end list node is null. And then we will write another constructor where we are asking different number of parameters, which will be, first of all, it will be in data value, and maybe user is also giving us the address. So how to denote that address will be the list node is the data type, like this whole class, like list node. So this will be next. This is our second constructor, and again we will just initialize our fields by taking these values from the user. This dot data equals to data, this dot next equals to next. So it will, again, this is from the very first week of the class where we have discussed about how this keyword works. Okay, so one thing about list node is that you don't have to make these two fields as private. So right now they are public. Why we don't have to make them private? Because list node class is not connecting or directly connecting with the client class. Client will call linked int list class. So let's create our new class. So this class kind of act as in the middle. As you can see, int represent that this class is of integer class. In the same way you can create for string, double, you can name it anything. I'm just naming it as linked int list, so that I know that this class represents linked list of integers only. So this is my class. I can do whatever I want with this class. Right now we are just recreating to see how Java has written all the built-in methods of linked list. So in this class, from our previous video, we have seen with the linked list, you need a front, or it's kind of a first thing, or the list who is holding your list. So linked list have a front, so this will be private. Why this is private? Because this class is directly connecting with the client. So client is interacting with linked int list class, so the fields of this class will be private. And what's the data type for your so the data type will be list node front. And then what we have is, okay, so after identifying the field, because this is kind of a linked list, so when this is a linked list, we have a field. Now we have to identify The constructors, they are always public. They have the same class name. LinkedIn list is my class name, and what we are not asking anything. This is kind of we are writing a default constructor because we are not asking any value from users. User will use our add method to add the values. We are just making sure to avoid any garbage value. We are initializing our front as null. So this is for our linked list class. Now you will write all the methods: add, remove, get, add, sorted, size, is empty, any methods which are available in the java.utility package, you can recreate over here in your own way. So starting with our add method, because that's the first method you have to write, because if you don't have add method, there is no point of writing print, remove, or toString, anything, because if user cannot add the value, how you can test rest of the methods. So public return type for add will be void, method name is add, and what we are asking from user is int data value. Okay, so we are asking what's the data. You can name it as value. The data type is integer because we are only working for integers value. When you are adding something to linked list, first of all, you have to make sure, or you have to go through with your front, because this is a front kind of a thing who is holding the rest of the list. So there are no indexes. You can assume the indexes, but there is no index A. You cannot say A of 0, is it null or what is it? So what we will do is, first of all, we will check front. If front is null, then it means add the value to the front. There is no front. So if front equals to null, it means front is null. So we will say, hey front, you are equals to new list node, like, and add the data value. So this class is interacting with the list node class. It will go to list node constructor and pass the data value, add the data, and the second section, which is next, will be null because this is the first value and the value is not pointing to anything else. Okay, so this is the case when front is null. Now let's write the else case where your front is not null. Remember from our previous video, whenever you have to go through your list, it means now we have to go through the list, right? Because there we are in else, it means we already have some couple of values in our list and we have to go at the end and add the value. So when you have to traverse, what you have to do is you cannot change your front, you cannot loop over your front. So the thing you do is you create your current. So list node current will be equals to front. You will just assign the same address. So current is also pointing to the same list where front is pointing, and we don't know how big is that list. We use while loop, while, and our condition is as long your current.next is not null. As you find the null part, so as long while current.next is not equals to null. So this loop will just take you to the end of the list, and that's what we want. And don't forget to write current equal current.next to increment your object, like the space. Like if you don't write current equal current.next, it will be an infinite loop. So you are outside of this loop. So this is where your while loop ends. So you are outside of this loop when your current.next is null. So when you found your current.next is null, what you will do is you will say, hey, current.next, you are equals to new list node, and pass the data value you have been given by the user to add, and list node class will automatically set the other section, which is the next part, will be null. Remember from your list node class, where is it? Over here. So it will go over here in this constructor and the address will be null, which indicates the end of the list, and it means this value is added at the end of the list. So this is your add method you have. So before testing this add method, we need to write our print method so that we can see if the values are actually added into our list or not. You can name this method as toString. So there are two ways you can write this method. One is you can return the string, return the whole thing as a string, or you can print in the same method one by one each and every value. Whatever works for you, you can go with it. This is the string. Let's name our method as toString. Just like in Java has toString method, and we always, so this is where you can do even your designing part. In this toString method, what we are doing is we are just going through our list, whatever, how many values we have in our list, and who knows the list? This front is holding the list. So you will check if front is null, so there is nothing to print. So if front is not null, it means you have some values to print. So as we are returning a string, you can create another string which is result, which is kind of an empty string, and this is the value you can return. Now what we will do is, so we will say if our front equals to null, then what we will do is throw new no such element exception. Okay, so okay, so now we have the else part. It means your front is not null, it is holding some value. So now again we have to loop through our code. So list node, I will say current equals to front, and you will have your while loop while your current is not equals to null, and inside current is not null inside of your loop. As we are going through now, it's not like the previous thing that you just have to reach the end. As you are going through, you have to print the values as well. So what we will do is we will, don't forget this result, because this result is holding your value. Result plus equals to double quotation mark, oh sorry, current dot data and semicolon. So, and before this, let's just to make it a little readable, put a comma between the values, and inside of your loop you will have current equal current dot next, so that it moves to the next node as well. And then I think that's it. First of all, we will test, and then we will come back if we need any changes or if the answer is wrong. This is where my while loop ends, this is where my else is closed, and return result. Okay, you have to return because as we are returning a string. Now let's test what we have so far. Another class which is our client class, and in this client class you will write your main method. And now what we will do is we will create our create an object of our linked int list class. So just name it as list equals to new linked int list, and list dot add 34, list dot add 50, just adding couple of values to see if our code works fine, and 22, let's say this. Now as we are getting a return, so there was no system.out or print statement, so it means we have to test the print code. You have to write system.out.println and list.print like this. Oh, it's not a print method, sorry, it was to string. Okay, now run our code. Let's see what we have. The output section. Okay, so we have 34, 50, and 22. So as you can see, a fence post problem over here, we have a comma which we don't need. So in the front, so it's working fine. It means list. Our add method is working fine. Our toString method is working fine. It's just the I would say a fence post problem where I have an extra comma in the front. So to avoid this, what you can do is you can add plus comma after it like this. Now let's see what we have. I think there will be an extra comma at the end. Yeah, so there is an extra comma at the end. So what we can do is you can say current dot next is not null, and in this way we will miss our last value. So let's see if what will be the change after that. So as you can see, I was right, so it will miss our last value, so 22 is not printed. To avoid this, what we will do is, so it means we are pointing at second last value, so this is where my while loop ends. So before while loop ends, I will print, or I will say result plus equals to current dot data and semicolon. So now our output will be fine, readable. As you can see, no extra commas at the start, middle, or at the end, and we have all the values into our list printed. So this is how you will test your linked interlist code. Rest of the coding is provided in your code. You can copy and paste and you can test, or you can write your own coding with get method, remove method, and you will be writing all the methods in your linked interlist class. So now the role for list node is done. Once you write list node class, you have identified like I need one data value and it will hold one address which will point to the next list node, like this, because you said list node is the one. So it will only loop through back to the same thing. Now whatever you want to make any changes, all the changes go in your link interlist class where you will be writing all the methods, and client is the class where you will test all the methods you have written in your linked interlist class. That's it for this video. Thank you.